Okay, let's go over 2, 3, and 4 here. So notice 2 is talking about an ordering of cards, which is different than choosing a hand of cards, because when I have a hand of cards, the order in my hand doesn't matter. But here it's saying, in how many ways can a deck be stacked such that the 12 face cards all end up on the top? So if I think about literally creating spots for like lining up the cards, say this here is the top. So I've got the top card, then this next to top, and so on. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I think about, okay, at the top is only face cards. So how many ways can that happen? Well, there's 12 face cards that can be at the very top. Then there's 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that's 12 factorial. And then if I think about continuing, because going on, it's going to be the remaining 40 cards, then that's just times 40 factorial. So again, here, order is mattering, so you're not dividing out order, because it's all about how many ways can I order the cards in the stack. Okay, and number 3, and notice again, we're not talking, just like in 2, 3 is not about probability. So think about, it's counting the number of ways a specific event can happen. So if you want to equate it to probability, it's like finding the numerator in probability. So I've got 12 families, each has 4 kids in the family, and we need to choose a group of 5 children, but they have to be from 5 different families. So I think the best way to handle this is, since they have to be from 5 different families, these 5 children, let's first choose the families. How many ways from 12 families can I choose 5 of them? It's kind of like similar to choosing a suit to be 3 of a kind, or unmatched cards, or a pair. So I'm choosing 5 different families, and within each of those 5 families, there's 4 kids, and I want to pick one of them. So 4, 1, 4, 1, 4, 1, 4, 1, 4, 1. And that's the number of ways that particular event can happen. Okay, so, and let's do number 4 here. So in number 4, whoops, I'll do that. Okay, again, we're talking about cards, but notice this is not probability. Instead, it's just saying, it's like the numerator of probability. How many ways can this specific event happen? So starting off here, we've got how many ways can, if deals 6 cards to his friend, if Bailey deals 6 cards to his friend John, and how many ways could he get 6 hearts? Well, there are 13 hearts, and how many ways can I choose 6 of them? Would be 13 choose 6. Part B is I need 3 hearts and 3 spades. So of the 13 hearts, I need 3 of them. The 13 spades, I need 3 of them. Part C, a 4 of a kind and a pair. Okay, so 4 of a kind and pair are 2 different things, so I'm going to choose their ranks separately. So let's do the 4 of a kind first. 13 choose 1, and then 4 choose 4, which is just 1. And then there's 12 ranks left, and how many ways can I choose one of those ranks to be a pair? Is 12 choose 1, and within those cards, that 4 rank, I'm choosing 2 to get the pair. D, 3 distinct pairs. So pairs are all the same type of thing, so I've got to choose the ranks all at once. From the 13 ranks, I want to choose 3 to be a pair. And so 4 choose 2 within one pair, 4 choose 2, within one rank, 4 choose 2 within another, and 4 choose 2 within the 3rd rank. And finally, a 6-card flush. That means 6 cards of the same suit. So instead of choosing ranks here, I'm going to choose the suit first. There are 4 suits. I'm going to choose one of them. And within that suit, there's 13 cards, and I want to take 6 of them. And okay, so that was 2, 3, and 4.